Alrighty, let's go ahead and go over the next set or the last set of questions with the from the POE semester exam review. Starting with question number 23, a circuit draws an electric current of 0.387 amps. And the supplied voltage is 7.2 volts. The circuit runs a motor to lift a 10 Newton mass. And that question is not written properly because the 10 newtons is not a mass. Newtons is a force, and so I'm curious if this should say grams or this should say force. Okay, so anyway, the distance though is 0.25 meters. I'm going to assume that this meant to say force. Okay, so a little mistake in that problem there. Now the time it takes to do that is 12.2 seconds. Calculate the efficiency of converting electrical energy to mechanical energy. So what I can do is I can calculate the power input from the electricity by multiplying current times voltage. And so 0.387 amps times 7.2 volts, multiplying these two values will give us a measurement in watts. And so I have an input power of 2.79 watts, just about. Now in the output, we're taking that electricity and converting it into mechanical power. And so mechanical power can be calculated by dividing work and time. But work is equal to force times distance, where force and distance have to be parallel to one another. And so force is 10 newtons times 0.25 meters. And we lift that force, or we apply that force across that distance in a time of 12.2 seconds. In my numerator, a Newton meter is a joule. And in the denominator, I end up with seconds, so a joule per second is also known as a watt. So for this, my output power is going to equal 0.205 watts. So to calculate the efficiency, we take and try to determine, well, how much out did we get compared to my input? And multiply by that by 100, and so I end up with an efficiency of 7.34%. Okay. So if I take a look at my answer choices, I see 7.4%. None of the other ones seem to be the correct answer. So my guess is that there's some rounding issue taking place here. So let me double check my work. Yeah, it's a rounding issue, and so 7.4% is actually closer because I think I rounded this one here, which affects it. So I will just make sure on the semester exam that doesn't take place. But anyway, this is the correct process. We just had some rounding issues going on here. All right. Number 24. The blank in coal is what is used to produce electricity through additional conversion methods. Okay, so anytime we have some sort of material that we are burning, so whether that be coal or gasoline in the combustion process, what we're really utilizing is the stored chemical energy in these materials. And that stored chemical energy is being converted into other forms of energy that we can then use. And so in question number 25, it says a combustion engine stored chemical energy. Oh, look, there's our answer right there. And the gasoline is ignited and then converted into mechanical energy to move your car. A combustion engine has an efficiency of about 35%. Most losses in a combustion engine are due to a couple things. They're due to sound energy, heat energy, friction, which then gets converted to heat energy. It says bad oil, which I guess could be one of the reasons why you lose efficiency. But the most appropriate answer would be heat and friction, so B and C. The blank in a body of water at high tide is what a hydroelectric dam utilizes to produce electricity. So again, in a hydroelectric dam, you have water that is stored on one side, and it gets released through this penstock and through this pipe, and you end up with water flowing. And inside here is where you have the turbine and the generator. But if you look on the other side of the dam, the water is at a much lower level. And because of this height difference, you have a lot of pressure built up on this side. There's a pressure equation, rho GH, where it's the density of water times gravity times height. And so the deeper the water, the more pressure that water has. And so since the water is not in motion yet until it gets to this point, what we have here is a stored energy, and it's known as gravitational potential energy. So because of that height difference, that water just wants to flow downhill. So gravitational potential energy is the appropriate answer here. Number 27, static equilibrium is a condition where there's no net external forces acting upon a body, and the body remains at rest or at constant velocity. Okay, so in one situation, like let's take a ball, for example. Let's suppose this ball is just sitting on a table and it's not moving. In another situation, let's suppose the ball is moving, but it's moving at some constant velocity v. All right, what does an object at rest and an object at constant velocity have in common? Well, they both do not have acceleration. Because if there's acceleration, that means that the velocity is going up or the velocity is decreasing for deceleration, right? But it's definitely not constant. So for this problem or this question, zero acceleration is the appropriate answer for an object that's either at rest or an object that's at constant velocity. Okay, they may not have the same weight because they could be two different objects. Gravitational force is the weight of the object. Now they have the same gravitational acceleration if they're both on Earth, but they don't have the same gravitational force. There's a difference between gravitational acceleration and gravitational force. So that's not correct, and they may not have the same mass. So the most appropriate answer is B. 28, a quarter inch 20 UNC bolt is driven using a 6-inch wrench. What is the IMA of the bolt? So again, I've got a bolt. And what this number tells me is that in my screw, there are 20 threads per inch. So for the pitch, the distance between my threads is going to be 1 over TPI, or 1 over 20, so 1/20th of an inch. So if you focus in really, really close and look at the distance between two threads on a screw, for this specific bolt, that distance is going to be 1/20th of an inch. Now, what I use to drive this screw matters, and it says we're using a 6-inch wrench. So that means that this dimension here is 6 inches. The longer this wrench, the easier it's going to be to turn. So for one turn of this screw, so if I turn this wrench once, my effort force covers the circumference of this circle that's generated. And with one turn of this screw, the screw's going to move down that pitch distance. So again, one turn of the screw, the screw moves linearly the pitch distance. So if you're wondering where this equation comes from, Because remember, IMA equals dE over dr. Well, what's the effort distance? The effort distance is the circumference that is generated by your hand motion. And the resistance distance, how far the screw moves, is that pitch distance. So that's where that equation comes from. So 2 pi r, my radius of that circle that's generated, is that 6-inch wrench. The resistance distance is that pitch, which is 1 over 20. And so that's measured in inches. So these are going to cancel out. And so I end up with 12 pi times 20, which equals 753.98, so about 754. And so we can see that it got split up on my review here, at least on my app that I'm using. So answer choice D would be the most appropriate answer. So again, 754 would be my IMA. So massive, massive mechanical advantage. All right, let's go ahead and move on to number 29. We're just about done. Handicap accessible ramp must cover a horizontal distance of 36 feet and a vertical distance of 3 feet. So we have this ramp here. What is the IMA when it's utilized as an inclined plane? So on the formula sheet, it is given to you that IMA is equal to L over H. And they document L as being the length of the inclined portion, or the hypotenuse, and H being the height of this triangle here. So what we need to do here is do Pythagorean theorem, a squared plus b squared equals c squared, so we can determine what this hypotenuse is. So 36 squared plus 3 squared equals c squared. That gives me 1305. Take the square root of both sides to cancel out the square root here to isolate my unknown variable. And I end up with a hypotenuse of 36.12. All right. So now I can go to my IMA equation. And they utilize L, but that's, if I were to push something up this ramp, that's the distance my effort would travel, so that's dE. The resistance distance is this vertical distance here. That's how much distance I overcome due to gravity. And so the equation is still dE over dr. They've just applied it to specifically an inclined plane, and they rewrote it as L over H. So in this situation, 36.12 divided by 3 gives me an IMA. And again, that's feet and that's feet, but they reduced to 1. That gives me an IMA of 12.04. So answer choice B. Which of the following are sources of renewable energy? Nuclear is not. Nuclear is not renewable. Coal is not renewable right off the bat there. That one's wrong. So answer choice C. Solar, wind, hydroelectric, and geothermal. All right, final question of the review. Compound machine is made up of a wheel and axle with a mechanical advantage of 2.5. A gear train. Okay, so we've got some mechanical advantages here, and we've got some gear ratios here. So 2.5, gear train with a gear ratio of 4. Wheel and axle with a mechanical advantage of 0.5. And an inclined plane with a mechanical advantage of 6. So 3 mechanical advantages in this compound machine and a gear ratio. What they want is the total mechanical advantage. Total mechanical advantage is the product of the individual mechanical advantages that make up your system. What it's not a combination of mechanical advantage and gear ratio. So you're not going to multiply this value through. So we end up with a total mechanical advantage by multiplying these 3 values of 7.5. So answer choice A. All right, that concludes the review for POE for the semester exam for the fall of 2020. Good luck studying and have a great rest of the day.